Okay, hello everybody. Welcome back to Just About Chemistry. All right, so we are going to solve this kind of problem. This problem is about the stoichiometry, but different to the other problems that we have worked so far. In this one, we will have a different mole ratio between products and reagents. So let's try to solve this one in the easiest way possible, because it will be one of the problems in your test. So please pay attention. All right, so we have this equation. The equation basically tells us about the decomposition of potassium chloride into potassium chloride to potassium chloride and oxygen. So the problem essentially tells us that we have 24.5 grams of potassium chloride and we need to find the number of moles of oxygen. So we have this amount as a starting material or as a starting point. What would be our procedure? So remember, there is an algorithm that we have to memorize, maybe just get a tattoo, and it is essentially this. Then we have to find the number of moles of everything before to go to complete any kind of problem. So once we have the number of moles, depending on the reaction, we have to look for the mole ratio. What is the mole ratio? It's basically how much is produced about something from something, or how much do I need of two things to produce certain thing, like a sandwich. The mole ratio between a slice of bread with jam, it would be like if you have a sandwich with 2 slices of bread and 1 of jam, your relationship would be every 2 slices of bread, you will need 1 slice of jam. So it's a mole ratio 2 to 1. All right? So if I have, for instance, 12 slices of bread, I will need 6 slices of jam, because that's the relationship, 2 to 1. Every 2, I require 1. So essentially, it is the same with this one, but different with cuisine in chemistry, and the mole ratios are not essentially kind of like easily to understand. Like for instance, the mole ratio that we have with the potassium chloride with these two is like this. We require 2 moles of potassium chloride to produce 2 moles of potassium chloride. So it means that the mole ratio, it is 2 to 2, or it is 1 to 1, because every mole of potassium chloride will form 1 mole of potassium chloride. All right? What happened with oxygen? We have a different mole ratio. Every 2 moles of potassium chloride will produce 3 moles of oxygen. So we have a ratio 2 to 3. Okay, so first we have to look what is the mole ratio that the question is asking us. In this case, it is asking us about the amount of moles of oxygen, but our starting point, it is 24.5 grams of potassium chloride. It means that the mole ratio that they are asking us is the relationship between these 2 molecules. Then in this case would be the 2 moles of potassium chloride with the 3 moles of oxygen. Remember that those values, the bigger values close by any molecule, are called stoichiometric coefficients. And the stoichiometric coefficients are the responsible of telling us what is the mole ratio in a reaction. All right, so now we realize that the mole ratio is 2 to 3. Okay? Now let's see what can we do with that information. So the first we need to do is every single data that I will give you or anybody will give you about any kind of problem, you have to turn that amount, grams, milliliters, I don't know, molality, it doesn't matter what is your starting material, you always need to turn it into moles. So if I have 24 grams of potassium chloride, I need to turn it into moles. So we have several options. Option number 1, it is using formulas. So we know that m, which is the number of moles, it is equals to the mass given, so it's just like a random amount of mass, with the molar mass. What is the molar mass in this problem? So the molar mass, it is nothing more and nothing less than the addition of all the atomic masses in a molecule. So we have potassium chloride. Potassium chloride will have 39 for potassium, chloride it is 35.45, and oxygen it is 16 times 3 because we have 3 of them. So if we do the addition of this, it will be 39 plus 48, which is 16 times 3. That would be 80, it would be 87, and 87 plus 35.45, it will be 122.45. And what would be the units of that? Please, if you don't write me the right units, I will just write in your paper apples, pineapples, pears, yogurt, pizza, Hawaiian pizza, whatever I like. Why? Because a number without units, it is just a number, nothing more. Remember my always example. If you have like an account and you have a bill and you want to ask for the money and you say, I don't know, you say like 20 millions and you don't use the right unit, I will pay you 20 millions of bolivares, and you won't say anything because you never clarify me. It is 25 million Colombian pesos, it is $25 million. So please, be aware about the amount of the units. In this case, the molar mass of every single molecule will always be grams per mole. So, if I replace that data over here, I will have that the mass, it is 24.5 grams, that is the mass given, potassium chloride, divided by 122.45 grams per mole of potassium chloride. Alright, so once we solve this is essentially, I believe I can apply, that is 0.2, if I'm not wrong. 0.2 moles of potassium chloride. Okay, so I found the number of moles of potassium chloride. Now that I have the number of moles of potassium chloride, I will relate it with the mole ratio. So we can use again formulas. So if I have 2 moles of potassium chloride over here, and those moles of potassium chloride produces 3 moles of oxygen, rule of thirds. So if I have 0.2 moles of potassium chloride, how many moles of oxygen will I have? Clear the equation. So just clear x moles of oxygen, and that will be x 0.2 divided by, so 0.2 times 3 divided by 2, and x over here. So it will be 3 moles of oxygen times 0.2 moles of potassium chloride, and that divided by the 2 moles of chloride. 2 moles of chloride. How much would be this? It would be 0.3 moles of oxygen, and that's it. Easy peasy. That's one way of doing it, using formulas, nothing more than formulas. I didn't use any complicated, anything, no, it is too complicated, teacher. No, it is just formulas, the same formulas that you already have. The only thing is barely new, it is the relationship about the stoichiometric coefficients, but just basically a rule of thirds, nothing more. It's just clearing the x, that's it. Let's do it using stoichiometry. So let's erase everything and let's use it. And let's use only stoichiometry. Everything in one single row. So we have 24.5 grams. That's not a starting information. We don't have anything else besides that. So we have to turn always into moles. So I know that potassium chloride, it weighs 125.45 grams of potassium chloride, and that's the equivalent of 1 mole of potassium chloride. Remember, the unit that we have, it's going to be down in the denominator, and the unit that we are looking for, in this case the number of moles, it will be above. And the units that we have in the ratio must be related. In this case, this is the molar mass, grams per mole. It is just twisted. Instead of being 125 grams per mole, it is 125 grams. 1 mole over 125.45 grams. It is just twisted because I need to cancel the grams, okay? Cancel grams with grams, and now I have moles. Then the mole ratio. What is the mole ratio? Every 2 moles of potassium chloride produces 3 moles of oxygen. So 3 moles of oxygen. But teacher, how do I know what kind of number used in this ratio? It is very simple. Just pay attention to the stoichiometric coefficients. And like you already know what is the unit that you have in the denominator, you have to use the unit to cancel that unit. So you will write mole of potassium chloride below, and the unit that you're looking for is the amount of moles of oxygen. So mole of oxygen, it will be above. Now, how to find the numbers? It is just the stoichiometric coefficient in the reaction. We have 2 moles of potassium chloride, 2 moles of potassium chloride. We have 3 moles of oxygen, 3 moles of oxygen. I'm not doing anything else than just writing down whatever I have there. And I just cancel this with this. And what will be my outcome? My outcome will be 0.3 moles of oxygen. And that is it. 2 ways to do it. For me, this is the easier one. But if you are not like very good using stoichiometry, logic and stoichiometry, you can use the mole ratio with the equations, with the stuff, and it will be the same. The only thing that matters is that the amount will be the same. And that's basically it. Very simple, isn't it?